Our aim today is a 9.9 Pythagorean identities and quadratic trig equations. Now, as a reminder, this is what a right triangle would look like with theta in standard position on the unit circle. If we were to apply the Pythagorean theorem, we would get x squared plus y squared is equal to 1. However, in a previous lesson, we learned that x can be replaced by cosine of theta and y can be replaced by sine of theta. Therefore, this Pythagorean identity can be written as cosine squared theta plus sine squared theta is equal to 1 squared theta, or simply 1. And also, as a way of reminding you guys, sine of theta divided by cosine theta is the same as y over x, which is our tangent ratio. So deriving the Pythagorean identities. Cosine squared plus sine squared theta is equal to x squared plus y squared is equal to 1 squared. It's a Pythagorean identity. However, there are two others, and we're going to do the derivations now. So the first, notice if we divide everything here by sine squared theta, we still have equality. So cosine squared theta divided by sine squared theta is cotangent squared theta. Sine squared theta divided by sine squared theta is equal to 1. And 1 over sine squared theta is equal to cosecant squared theta. And the second, if we divide everything by cosine squared theta, again, we have equality. And we get the following. 1 plus tangent squared theta is equal to secant squared theta. So here are the Pythagorean identities listed again. So quadratic trig equations. So here's your question. For all angles in which theta is less than 360 but greater than or equal to 0, find all and round them to nearest tenth of a degree for the following equation. So notice here we can factor out tangent of theta. Notice how it's a quadratic because it has a degree of 2. So just like any quadratic, we have to make everything equal to 0, and at which point we factor out tangent of theta. And because of the zero property, zero multiplication property, we can set tangent of theta equal to 0, or 2 tan theta minus 5 is equal to 0. And when you perform the inverse operation, well, first we're going to solve for tangents for both. Then we're going to perform the inverse tangent operation. And when we get that, we get 0 degrees, but also 180 degrees would work as well for quadrants 2 and 3. And the inverse of tangent 5 over 2 would be approximately 68.2. And since tangent is positive in the third quadrant and 5/2 is a positive ratio, we would add 68.2 to 180 degrees to get 248.2. Therefore, our final answer is these 4 equations. These 4 degrees. 0 degrees, 68.2 degrees, 180 degrees, and 248.2. Now for another example. So here we have another example. However, this one, it's also quadratic, but it's not equal to 0 yet. So we're going to transpose the 2, but here's a twist. We're going to, instead of dealing with the ratio, we're going to substitute another letter for the ratio, and we're going to solve it just as we would any quadratic equation. So when we transpose the 2 and replace u with cosine theta, we get 8u squared plus 2u minus 3 is equal to 0. And when we factor that, we get the following. And when we solve, we get that u is equal to -3/4 and u is equal to 1/2. We then use this information and replace u with cosine of theta. So now we're going to perform the inverse functions for -3/4 and also for 1/2. Now notice -3/4. Ask yourself, when is cosine negative? Well, it's negative in the second and third quadrant. So we're going to have to determine what that reference angle would be in order to figure out what those values are. So when we plug this into our calculator, we would get 138.6 degrees. However, the reference angle there is 41.4 degrees, or its distance from 180. So you add that 41.4 to 180, and you get 221.4. And then for cosine of 1/2, we get 60, and since cosine is also positive in the fourth quadrant, we do 360 minus 60, or 300. So your four solutions are 60 degrees, 138.6 degrees, 221.4, and 300. Your homework today is delta math. Scrap paper is required.